One of the big challenges for standardization using molecular methods is that of quantification. Molecular methods are used quite often for presence or absence. You can think of sexually transmitted infections as an example, or even genomic testing or genotyping of patients. But where you're trying to quantify the presence of something, it becomes much more challenging. When thinking about standardization of nucleic acid measurement, DNA measurement for example, we think about the PCR, we think about the sequencer, but we have to do a large number of procedures to get to the DNA into that sequencer. All of these steps can add error or uncertainty. qPCR can get a very precise measurement, but it can be quite challenging to know the accuracy, and it needs calibration. You need to have some kind of standard to which it can be compared to. Digital PCR is like a digital radio. It gives you the results, bang, there they are. It counts the individual molecules. You're no longer dependent on an amplification curve that you require on qPCR to give you the actual signal of what you're measuring. Digital PCR is able to do that because of the partitioning that occurs that essentially gives the individual molecules their own individual PCR reaction, and it has much greater sensitivity. By looking at the metrology, by looking at the measurement science, we can really get deeper and deeper into what is possible. Digital PCR could have a major role here in ensuring we get global standardization. The promise of the genomic revolution is there.
QIAGEN.
Sample to insight.